Okay, let's take some time looking at this this idea of an investigation. So this is really targeted at my grade 9s who are just seeing these for the first time. So I'm going to it's slightly different to some of the usual ones. I'm going to today just kind of really talk about what the mark scheme entails and kind of how to get started on this type of question. You'll notice obviously I've got a couple of things up here. I will just clear that so the starting point is just the same, and we're looking at this paper 6 investigation. So a couple of things to notice first of all, and we will talk about the marks as we go through this time. 20 marks in total, and this should take about 45 minutes is the guidance that we're given from the paper. Okay, let's dive into it. First things first, this information, all this writing at the top, is going to be really important, and it's really important that you engage with this and kind of see what it's trying to lead you into. They're always going to, with these paper 6s, whether it's an investigation or a modelling, they're always going to start with a numerical example, give you a chance to hopefully get a feel for what's going on, so that then you can apply it in a more generalised context in future. So let's just look at what this is starting with, and I am going to read this out, even though you're obviously very capable of reading. So the investigation is about finding numbers that have the same number stem. So that's something that we don't know a number stem, so hopefully it's going to tell us what a number stem is. Possible number stems are the 9 integers from 1 to 9. Here's how to calculate the number stem of a number. Okay, so we've got these steps here. Step 1, add the digits of the number to get the total. If the total is 9 or less, stop. Okay, kind of makes sense. Otherwise, add the digits to the total, repeat step 2. Okay, quite tricky to kind of see what that is, but actually let's just have a look at what we've been given. And we've been given an example of number 124. So we add the digits 1, 2 and 4 to get an answer of 7. Now that 7 is 9 or less, which means I need to stop. So I'm stopping here, and 7 is my number stem. Okay. Hopefully they give me an example of where I don't stop, and that's what we've got here. So we've got 893, which means we add together 8, 9 and 3 to get 20. Now 20 is not 9 or less, so we need to add the digits of the total. So take your 20, add together the 2 and the 0, and we get an answer of 2. Now it's 9 or less, so now we stop. And our number stem here is 2. Okay, so it's kind of really kind of breaking down number in some sort of parts, I suppose, but let's just have a look at kind of what we're going to be asked to do in order to kind of apply this. So question 1a. Complete the tables to show the number stems for the multiples of 3 and 12. So we need to go through this process of finding the number stem for these numbers. First of all, 15. So this process, what I'm going to do is 1 plus 15. 1 plus 5 to pull apart my numbers. 1 plus 5 is 6, and I need to stop because 6 is 9 or less. So I'm going to fill in 6 here. Okay, that was quite straightforward. And I'm quite confident in my answer, because if I look at this table that we've got here, it seems to be a nice pattern I'm spotting already. 3, 6, 9, 3, 6, 9, 3, 6, 9, 3. And my answer that I got kind of fit with that. So I feel quite happy that that's perhaps going to be correct. Next one, we've got 48. And so I'm going to take my 4, add it to 8, I'm going to get 12. Now that's larger than 9, so I need to take the part again, 1 plus 2, which is 3, and at that point I can stop. So this one is 3. For 60, 6 plus 0 is just 6, and I stop there. For 72, I'm doing 7 plus 2, which is 9. Okay. 84, is going to be 8 plus 4, which is 12. Oh, I need to again do 1 plus 2, which is 3. Okay, next one, 96. 9 plus 6 is 15. Okay, let's go again. 1 plus 5 is 6. 108, 1 plus 8 is 9. And 121 plus 2 is 3. Okay, so I've filled this in with what I'm filling, and I'm going to reflect on the answer that I got. 3, 6, 9 was given to me to start with. Is there a pattern again? 3, 6, 9. Oh, it seems like there is. 3, 6, 9, 3, 6, 9. 3. Okay. So So let's have a look at what this is asking us to extract next. We're going to look at some specifics from what we're dealing with. And what do we have here? We've got to complete the sequence to show the first 4 numbers greater than 3 that have a number stem of 3. Can I get rid of this microphone, I wonder? That's getting rid of it. I wonder if I haven't ticked that. Nope, that's not helping. What about if I press that? Ooh, it's disappeared. Oh, we're back. Okay, we'll see if it disappears. Oh, hopefully that makes things a little better. Okay, complete the sequence to show the first 4 numbers. Oh, this wants my attention. Let's go back. Greater than 3 that have a number stem of 3. Okay, so we're focused specifically on number stems of 3. So it's given me, well, I know 3 as a number stem, but it's saying greater than 3. So we're not going to concentrate on that first one, but we've got 12 here, which is a 3. We've got 21, which is my next 3, and then my next 3 is 30. So it's telling me that these 3 are the first 3. Now, what have I got down below? I've got 12, and then I've got 48. So that suggests to me that 48 could be an option, and that's one thing that I need to consider. So it could be 48 if we're looking at the second lot of number stems. I'm just going to get rid of some of my highlighting actually. I probably shouldn't have highlighted. So 48 is one of my options that I'm considering if it's following these multiples of 12. But I wonder what would be the next one here. We counted 3 of them, didn't we? So we accounted for these 3 in here, here, and here. What would come next in this? Well, it's multiples of 3, and what I need is from here I need to miss a couple and then get the next one. Oh no, miss a couple and get the next one, which means it would be, well, not 33, not 36, but 39, I think would give me a number stem of 3. Let's just check. Let's go through the process. So number stem from 39, 3 plus 9 is 12, 1 plus 2 is 3. Nice. Now 39 is a better answer than 48 because it's asking for the first with a number stem of 3. Now you could check your answer and do all of the numbers between 30 and 39 to check, but I think you'll see quite quickly that you're not going to achieve any better answer than that. So 39 is the next one. Now find the nth term of the sequence in part B1. So how do we work out the nth term of the sequence? We need to look at what it's going up in. And here we're adding 9 each time. So if we're adding 9 each time, it's going to be 9 lots of n because we usually use n for sequences. And because the first term is not 9, it's not exactly my 9 times table, but my 9 times table shifted up 3. I would add 3. It's going to be 9n plus 3. Let's get rid of some of my workings there because they're not really helping now that we've answered it. So 9n plus 3. Okay, on to the next page. Yes, so marks as we go. Sorry. There's 1 mark here for getting this 6 correct. Let's put that in red. There's 1 mark here. And for... Oh, in fact, no, there's not. There is not. There is 1 mark for getting all of these correct. 1 mark. For getting the 39, that's worth 1 mark. And 9n minus plus 3, or equivalent, gets me 2 marks. Generally, most of the time on these paper 6s, where each section of a question is generally worth 1 mark. Okay, part 3. Find the 87th number greater than 3 that has a number stem of 3. Well, that's using this expression that we just found. So using 9n plus 3, we are now going to input, we want the 87th one. So 9 lots of 87 plus 3. You might be good at your 87 times table. I'm going to reach for my TI Inspire. 87 times 9 is 783. I need to add 3 to that, and we're going to get 786. for 1 mark. Okay. Now, complete this table. Right, let's have a look at what's going on here. So we're given some numbers. So these numbers down the side are given to us. Well, the first few are anyway. Number stem, that's something that we're used to calculating. And then what they seem to be doing is taking the first number and always dividing by 9. So it's trying to spot what's going on here. Okay, so the first thing I would probably spot is that we seem to be dividing by 9 every time. So I'm going to put in this 9. Let's just check what happens when, well, 22 divided by 9 is 2 remainder 4. That's quite a quick calculation in my head. Now my number stem for 22, just to finish that row, would be 2 plus 2, right? So that would be 4. Okay. 35, I can calculate my number stem. 5 plus 3 is 8. And 35 then divided by 9. Well, let's just think. 9, 18, 27. Then 36 is too high. So it's 3. Remainder 8. Okay, now something with a number stem of 7 is what we're really interested in here. Oh, in fact, number stem is just 7 here. So let's have a little look and see if we can get to an answer for this one. Complete this table. Okay. Well, there's not a huge number of clues here for what we're doing with 7. Why don't I just think of a number stem that gives me an answer of 7. So I'm thinking if this is increasing every time, it could be 43. 43, the numbers would add together to give 7. That might be quite helpful for me, just help me get on board with what's going on. So 43 would be what I would, 43 divided by 9. So there's going to be 4 here. And I'm not convinced that I've done the right thing here, but let's just stick with it. 27, 36 would be 4 remainder 7. Okay. One of the things that I'm noticing then when I'm looking at analysing this table is these numbers appear to be the same throughout. So that's been the first thing that really stands out to me, the number stem and the remainder when we're dividing by 9. I don't know why we're dividing by 9 yet, but they appear to be the same. Okay. Part 2 then. A number that is not a multiple of 9 is divided by 9. What is the connection between the number stem and the remainder? So this is why we're doing it. That's exactly the point that I just made, which is they are the same. And for part 3, use your answer in part C, part 2 to write down the remainder when 1040200100 is divided by 9. Okay, so this is pointing me towards obviously not just plugging it into my calculator, but using the idea of a number stem. So I need to add these numbers together, which is just 1 plus 4, which is 5, plus another 2, 7, plus another 1, which is 8. So my number stem is 8. Which implies the remainder is equal to 8. Okay, let's just look at how marks are allocated. Okay, so yeah, looking back, this table, done correctly, is worth 2 marks, and there's some options on what you could have put here. 43 obviously works, but what we just needed was it had to be a number with a number stem of 7. So 2 marks for getting that correct. They are the same as worth 1 mark, and for getting 8, that's another mark here. Okay, we're making good progress through this. We're on question 2. Looks like there's only a couple of pages left on this section. Sequence shows the first 3 numbers greater than 2 with a number stem of 2. Okay, so let's just reset and try and really figure out what they're dealing with here. The bit that this reminds me of immediately is way back here, with when we were looking at this question, first 4 numbers greater than 3 that have a number stem of 3. It's very similar wording, and what I was interested in was those number stems of 3. Now, what we're interested in now is number stems of 2, and they've given us the first 3. We need the next one. Now, we don't have the table here to kind of refer to and look at. In fact, none of these numbers have a number stem of 2, so we know that those numbers are not going to help us. But let's have a look at the ones that we've got. So we've got 11, 20, 29. Now, if I think about this, 29... Well, as soon as we go into the 30s, we're going to have to do the thing where we stop and then calculate the digits again, aren't we? But perhaps we're also spotting a pattern here. And the pattern that I'm spotting is that this appears to be going up by 9, and this appears to be going up by 9 again. So I wonder, my thoughts are just at the point, well, is it going to go up by the same again? Let's test it and see. If I go up by 9 from 29, that's 38. Let's just test this, 38. What's going on with a 38? So 38 would have a number stem, of 3 plus 8, 11, 1 plus 1, 2. And I feel confident that that's going to be what my answer is here. So I'm going to go with 38 here. Oh, the next 2 numbers in the sequence are, so that was this 38. And if I go by the same idea, add another 9, that's going to be 47. Okay, the nth term of this sequence. Okay, it's going up by 9s again, 9n. Now it's not the 9 times table, it's 2 higher, so it's 9n plus 2. Using your answer in part B, find the largest number less than 10,000 that has a number stem of 2. Okay, so we need to find a large number close to 10,000 that will give us a whole number when we multiply by 9 and add 2. Okay, so there's a number of ways of doing this. I might say, well, what about if I did 9n plus 2 is equal to 1,000? Let's see what happens here. Well, I can solve this by subtracting 2. 999, sorry, it's 10,000, I've only put 1,000. 9998. And if I do this, it's not going to work, is it? 9998 divided by 9. I can already tell it's not going to work. It's not going to work, sorry. And I can see what that is. It's 1110.89. Okay, so I wonder what happens when n, instead of trying to do that, why don't we make it the whole number that's closest? Why don't we make n be 1110? Let's plug that into this formula. Let's see what happens here. So it would be 9 times 1110 plus 2. What does that equal? I might just box this off just because it looks like my workings follow. And I've got to be careful that I'm communicating this stuff quite well. So that's different workings. What if I take now 1110, multiply that by 9, and then add 2. Well, that's going to give me an answer of 9,992. Now, if we're saying that it's going up in 9s, which is what we said back here, it was plus 9 each time, plus 9, plus 9. Now this is in the sequence, it's the 1110th term in the sequence, and if we think about when we add 9 to this, it's going to go over that 10,000 threshold that the question's asking me to try and stay underneath. So my answer here will be 9,992. Okay, question 3. The integer k is a number stem. Okay, right, some algebra going on. Write down in terms of k the first 4 numbers greater than k with a number stem of k. Well, what we need to do is we need to generalize from what we've seen previously. So what we had before was 9n plus 2 for numbers greater than 2 with a number stem of 2. Previous to that, we had greater than 3 with a number stem of 3. Now, one of the things that I noticed that was consistent across both my answers was we ended up with 9n both times, didn't we? 9n plus 3 for number stem of 3, and 9n plus 2 for a number stem of 2, which is making me think that it's going to be some form of 9n plus k. Now the first one was just 9 plus k, then it was 2 lots of 9 plus k, 3 lots of 9 plus k, or 9 plus 2, 2 lots of 9 plus 2, 3 lots of 9 plus 2. And we're generalizing that idea. So this pattern that we've seen emerging from 2 and 3, we now need to generalize in terms of n's and k's. So for this first one, the way that I'm thinking about this is being 9 plus whatever k is. And let's just revisit that a second, because this is quite the tricky bit that unlocks the rest of the answer here. What I'm saying here, what I've spotted is that if I look at 9, I need to add 2, this 2, in order to get to 11. And the reason I spotted that twice is because if we think about 9 were being here, we would have to add 3, this 3, in order to get to 12. So what I'm saying is, whatever k is, the number stem that we're interested in, we add that to 9 to get our first term. Now, it was 2 lots of it for the next one, or 2 lots of 9, which is just 18, plus a k, 27 plus a k, and 36 plus a k. Now, in terms of n and k, well, that was this, wasn't it? 9n plus k? Yeah. So it's 9n plus k. Okay. Complete this table. What we've got is 7 divided by 12 is 0 remainder 7. 15 divided by 12 is 1 remainder something. Well, we can work that out, can't we? 15 divided by 12 is 1 remainder. Sorry, just get my pen correct. One remainder 3, right? And 23 divided by 12, we're still not at 2 12s, so it's going to be 1 still. Now it's remainder 11. Okay. I'm a bit uncertain as to what I'm being asked to do here, still, but that's fine. We've just got to roll with this and try and answer the questions one at a time as they come. Okay, part B then. An integer that is not a multiple of 12 has a remainder f, okay, when it's divided by 12. Find in terms of n and f the nth term of the sequence of numbers greater than f with a remainder of f. Golly. Now let's have a little look at what we were doing previously. The previous answers are always going to lead us to what's going on here, and we'll try and make sense of it. Now, the last one that I looked at was like this. It's this table here, where we divided by 9, didn't we? And we found that we were getting this here. And that's the only one that I'm kind of looking at that looks similar. But in this instance, I'm dividing by 12. So an integer that is not a multiple of 12 has a remainder of f when it's divided by 12. Okay, so there's going to be all sorts of, there's 11 opportunities really in between our multiples of 12. Find in terms of n and f the nth term of the sequence of numbers greater than f with a remainder of f. Well, they're going to go up in 12s. So it's going to be 12n. Now let's just have a look and see if this is going to help us. An integer that is not a multiple of 12 has a remainder of f. Okay, so f is the remainder, so it's going to be all of the multiples of 12 plus that f. Okay, show that f plus 10 cannot be a term in the sequence of numbers greater than f with a remainder of f. Well, if that was the case, f plus 10 would have to equal that expression that I've just figured out, 12n plus f. Now, that's quite an easy thing to look at. We can subtract f from both sides, and we get 10 is equal to 12n. Which is implying that n is not a whole number, or not an integer. Oof, that was quite tough to finish with, and that's us done there. Now let's just be mindful once again of where the marks are awarded. This last one is worth 1 mark. Previous expression was worth 1 mark. This table itself is worth 1 mark. Yep. And I didn't do it on the previous page. So 9n plus k is worth 1 mark. All of these together are worth 1. 9992 is worth 2 marks. 9n plus 2 is worth 1. 38 and 47 is worth 1 mark. And I've done it all previous to that. Okay, so in summary, there's a likelihood when you're starting off on these paper sixes that you're going to at some stage kind of feel almost out your depth and a little bit uncertain about where you're going. Hopefully, as I talked you through how I thought of it, you could see that I was at points, I'm not sure why I'm doing this, it doesn't make sense. And then what the paper is going to try to do is going to try to link what your thinking is at that stage to something that's gone previously in terms of your application of numbers. In this instance, it's pulling apart the numbers, and there's lots of different creative ways that the paper 6 can do that for you. Now, the only final thing to just mention is that if you added up all the marks that I've assigned here, then it would come to 19, and the total is actually 20. Now, in these questions, there's also opportunities to get communication marks. And that is basically ensuring that you're writing down your workings. So the opportunities that we're given for communication marks is 1B part 3, and that is writing out this calculation. That would get you an extra mark. That's your C opportunity. For 2 part B is the next one. And that's probably, although it should be down here, is this showing that we add 9 each time. So that's your next communication opportunity. And you only need to get one of these. And then 2 part C, which I think was quite a tricky one. Hang on, I've lost it. 2 part C. Yeah, so I kind of struggled for space in here, but it's showing that you're multiplying by 10,000, or you're doing some sort of substitution in this section here. So you'll get an extra mark for communication if you've done that communication well. Okay. We're going to get more familiar with these. We'll do a lot of them, and we'll work through them, and hopefully with time you're going to feel more confident with them. Hopefully this helps and you worked it through, and we'll do some more very soon.